Hello students, today we are going to discuss about Zener diode. So Zener diode is nothing but it's a special purpose diode. It's the application of the same junction diode which we were already discussing about. So basically Zener diode is nothing but it's a junction diode, but it is developed for some different purpose. So let's understand for what purpose this Zener diode is developed. Zener diode is developed just to operate in reverse bias under breakdown voltage. So now you may think, what is this breakdown voltage? So let's understand that first. For example, at your home, if there is a fluctuation in current, many of the electronic devices at your home will be getting damaged. Not only electronic devices, electrical devices also will be getting damaged. Right? Let's take an example of an electrical device which is a bulb. So continuous fluctuation of current will be causing damage to that bulb, right? So how it is happening? Because that particular bulb was having a particular capacity. So if there is a fluctuation in the current which causes a damage to that bulb, how it happens? Because that bulb is having a particular capacity, right? So if the flow of current had crossed other than its limit, then it will be getting damaged, right? Which means it is in the breakdown. So same like that, in an electronic device, when we are making use of diode, then if that particular diode is coming under breakdown voltage, which means it will be in the reverse bias, the current will be getting decreased, right? The flow of current will be getting decreased. Then how we can operate that? That thought made the great scientist Zener to invent his Zener diode. So Zener diode is basically developed to operate under reverse bias, in breakdown voltage. Okay, so now you know for what this Zener diode is used. Now let's understand the formation of a Zener diode. Zener diode is formed by doping the P side and N junction, P and N junction of a diode by heavily doping, which means when we are heavily doping both the junctions, then it will be the width of the depletion layer will be very thin, which means the conductivity of that diode will be very much increased, because we are what we are doing, we are doping P junction and N junction of a diode, right? So that its conductivity will be getting increased, so that the width of the depletion layer will be getting decreased, which means we will be having a very thin depletion layer. So when this width of the depletion layer is getting decreased, what is getting increased? Nothing but the flow of current, which means the conductivity will be getting increased. So when it is heavily doped, the reverse bias, the IV characteristics of reverse bias, which means for a very small reverse bias also, the IV characteristic will be like this. I'll use another color so that you will be able to understand it clearly. Forward bias and reverse bias will be coming over here, and it will be coming constant. There won't be any change, which means your device, the electronic device which you are using, if it is protected with a Zener diode, then it won't be getting damaged, because once it reaches the breakdown point, then it is not conducting any voltage, right? Which means even if we are using a small reverse bias voltage, even if it is by mistakenly also, if there is any small reverse bias voltage is there, suddenly this Zener diode will be bringing that particular device into breakdown voltage, so that after that there won't be any conduction. It will be helping the particular electronic device wherein this Zener diode is used. So Zener diode is one of the most important application of the PN junction diode.